Alex, good to see you this morning. How are you doing?
Good to see you as well. Thank you so much for having me virtually on the show today. I'm really excited to be here.
Great. So you are the founder of Snorker. It'll be great if you can introduce the company and your background in terms of how you got there. It's another successful startup out of Stanford AI Lab.
Awesome. Yeah, no, I'm excited to talk about that and the whole journey back from the Stanford AI Lab days. So I'm one of the co-founders and CEO at Snorkel. I'm also on faculty at University of Washington. And Snorkel was started really as a research project and eventually research center back at the Stanford AI Lab, along with my co-founders, Chris Ray, who's a professor at Stanford, and a bunch of the other core contributors and students on the project who spun out to create the company. We started back in about 2015, and really the vision was to unstick people from where they were blocked and stuck on, which was the data. And we were seeing this emerging trend where an incredible Cambrian explosion of ML models and techniques that were pushing the field forward, just gathering steam back in 2015. And a lot of these are, what you call deep learning methods, but not just the techniques, the tooling, the landscape, the infrastructure, the excitement in industry, and the actual adoption. And looking at this wave, we saw that some of the pieces in the machine learning pipeline that had traditionally been where people got stuck and where thousands of hours of PhD effort on the academic side or engineering team effort got spent was used to be just around the machine learning models or the algorithms that actually makes the predictions or does the actions that we leverage AI for today. And we saw this wave happening where a lot of this stuff was becoming not just more powerful, but also more accessible and push button and automated and effectively commoditized in some sense. And so, like good pessimists, or I could just non-jokingly say academics, we asked ourselves, well, where's the pain point shifting? It's got to shift somewhere. We don't believe in free energy. So we saw from talking to hundreds and hundreds of practitioners that we were fortunate to get to chat with, academic side, industry, government, et cetera, that a lot of the pain was shifting to the data, because these new machine learning and AI techniques that we all use today and were gathering steam back then are extraordinarily data hungry. And so we set out to explore what would it look like if we put data at the center of the iterative development process and really build what we call a data-centric AI system, where as an ML engineer or a data scientist, your day-to-day development loop is really about manipulating and engineering and labeling and slicing and doing all these operations on data, the data that feeds AI models, rather than just viewing the data as this upstream thing that you don't touch or barely touch, and viewing only the model as your kind of your development focus. So this shift from kind of model-centered to data-centric AI really changes a lot of things about what the AI development workflow looks like, and we set out to explore that with we always have to have a goofy title for the project back in academia. So we called the project Snorkel with this little blue octopus logo. I can go in details about how we thought of that later, but basic idea was, let's see if we can put data at the center of the workflow and also make the way of labeling and manipulating it more programmatic.
If you think about oil, like data, been around all around us, but only when we actually figure out how to process that oil from the earth and then refine it, and then figure out how to create the right kind of petrol products, and then with the engine, which I think we call AI nowadays, and then we can be able to process that, harness the power of the oil, right? So now, if I use the analogy of what you're describing, Snorkel, or the company you're working on, is really helping this massive data that are already out there, trying to make it easier to digest that massive data to be able to understand using the AI engine. To do it, you have to figure out how to process, you have to process it, mark it, and then refine it. And this is what you're doing in your data journey. Is that a reasonable comparison?
That's a great metaphor, and we used to have a phrase we said, which was playing off the old "data is the new oil" phrase, or is that data actually needs to be refined exactly as you said, and often the kind of refined form is what's called training data. This is what machine learning models learn from. It's not just data, but it's data that's been labeled and curated to teach machine learning models. And so we used to have a slide in our academic presentations that had a big oil drum and said, training data is the new oil, which was our cheesier way of saying exactly what you just put your thumb on. And maybe to make it more concrete.
Truth is, this is a huge industry, right? If you think about oil, really drove industrial revolution, and last 150 years, that's what dominate and involved and evolved our economy. If you really believe data is the next oil, we think next 100 years will probably driven by this whole data evolution, revolution, and the data and AI is going to become center of our livelihood, whether you are technologist or not. And I think what Snorkel is trying to do is enabling that journey, right? Is that reasonable?
Absolutely. I mean, to try to continue the metaphor a little bit here, one of the incredible things, and this is the trend that motivated the whole Snorkel project and that continues in force today, is it's almost as if people are giving away Ferraris for free out there, right? Things are getting faster and more powerful and more accessible really in the open source, all the machine learning AI tools, but they need this oil and they need to be refined, right? And it's not just good enough to stockpile crude oil. It has to be carefully refined for every single, and now I'll drop the metaphor for a little bit, for every single task you want to do. So maybe I can give an example to make it concrete. We have one set of work that we did along with the Stanford Healthcare and VA healthcare systems about using AI to help triage medical monitoring. Imagine, chest X-ray comes in the system, and this is motivated by low resource hospital systems where they're overwhelmed by medical inputs to read with limited doctors. And the goal is just to say, is this urgent and needs to be read by a doctor immediately or not? So it's a simple, what's called binary classification problem. And in this case, to use that metaphor, we were kind of, if you look at the Stanford Hospital or most medical systems, you're kind of sitting on all this crude oil. You have hundreds of thousands of, let's say, chest X-rays. But the key is refining them. And in this case, that means getting a doctor to label them as, in this case, urgent, not urgent, to teach the model to make this decision. So this is what's called training data. And the bottleneck is not so much getting the raw data in many of these settings in the world like this one, but it's about actually labeling it. So to label it, to teach this machine learning model took on average 8 to 14 person months in the paper that we published on this. Conversely, training the model and building it took about a day or two. So this gives you a sense of where the bottlenecks are today. It's really around that oil refinery process, not the engine. The engines have been built and are available in incredible force today.
Mm-hmm. It reminded me of another project that I was involved at Samsung side and HARMAN. We were involved in working on autonomous driving project. So most people may not know, but to make it the automobile drive safely, people are working on automating the driving experience. And to do it, you have to kind of know what's out there in the road, right? And you got the road signs, whether it's a stoplights, whether it's a road signs of speed, whether it's an exit signs. All those signs sounds trivial because humans are already trained and recognize it as a part of our process. But the camera, radar doesn't know that. So you take those inputs from the different input device, and then you have to figure out what those things means, and so that you can take an action. And in the process of getting that information and then labeling it, and then being able to do it is done by humans, right? You have to do it one by one, go through the pictures, and then train using AI to automate the process. But at the end of the day, it's very labor-intensive process. And I think what I understand is Snorkel is trying to solve that problem, for instance, by using machine to make it easier to do. Can you tell more about how you are trying to do this?
Yeah, no, that's exactly, again, the goal in a nutshell. And so the not so hidden secret of AI progress today is that all these advances, whether it's in self-driving or in the medical sphere or really it's touching all industries, is that the majority of this recent progress is kind of behind the curtains. There is a huge army of people that are clicking one by one to label data, whether it's stop signs or chest X-rays or whatever it might be. And that's what this all rests on. So the goal of the Snorkel project, more specifically than just putting data front and center, is to try to automate and make that labeling more programmatic. And this isn't, a push button auto magic process. It's still a human in the loop, but it's a human who's more directly telling the model what to look for. So it's a doctor sitting down and saying, look for these patterns, look for these words in the nurse's report, or look for these kinds of patterns in the image, et cetera, rather than just clicking stop sign, not stop sign, stop sign, not stop sign, a million times. And this idea of labeling programmatically enables it not just to be faster, but also more auditable, more adaptable. You're kind of taking this training data and you're turning it from just a pile of manual labeling that takes a huge amount of time to a code asset that you can now do much, deliver much faster, but also audit and change and govern, et cetera. So it's important for enterprises, those other aspects too, not just the time to value.
So the good news is human intelligence is still needed, helping to train, but then machine learns very quickly and being able to sort a lot of data much more volume. In the process, tell us about how the machine learning process can actually shape it even better than human can do. That may be interesting for our audience.
Yeah. So one of the big grand challenges in a lot of AI work is trying to bridge expert knowledge that lives in humans' heads and you can express as heuristics or rules or patterns with these the power of these modern machine learning or statistical based algorithms. And so Snorkel is one attempt at that. Again, is trying to take these we call them labeling functions, but having an expert sit down and write down those heuristics, like look for the word malignant in the report, look for this kind of a jaggedy edge. And these heuristics are going to be not 100% accurate and kind of messy. And so Snorkel Flow uses theoretically grounded algorithms to figure out how to actually kind of reweight and combine them and clean them up into clean, refined oil for the machine learning engine, to go back to that metaphor. So it's kind of automating to assist this process, but there's still a human in the loop who's kind of imparting the expertise. And in our opinion, whether it's Snorkel or not, we think it's always going to be the case that you're going to have someone, and increasingly, not just a data scientist, but often a subject matter expert, a doctor, a lawyer, a network technician, an expert driver who's imparting this knowledge and trying to make the process more accessible to them is another goal of the Snorkel project and a lot of what we do.
So when you're using this human training, and in a way also you could create a bias of that trainer or human intelligence. How do you make sure the bias is managed properly so that it doesn't take it the wrong direction?
It's a great question. Whether you mean bias in the kind of technical sense of a type of error mode, or in the in the very important kind of social senses that it can rear its head. Our view is that the first step. So first of all, my opinion is that it always has to rely on vigilance at the organizational and the process level. If you don't prioritize trying to identify and proactively mitigate bias in your systems, then no kind of algorithmic trick is going to make up for that. But if you have that process and that organizational level mandate in place to actually look out for this bias, the next question becomes, how can you actually correct it? And one of the big problems with AI today in the kind of old way of doing things, where you're manually labeling data points, imagine someone labels 1 million faces or 100,000 chest x-rays or pictures of stop signs. Going back and figuring out where the bias is and correcting it is as hard or harder theoretically than the initial problem you're trying to solve by labeling that data for months and months. Conversely, and this is one of the big goals of the Snorkel project, if you're labeling data with code, you can go back and you can change the code to correct those biases just like you would with any other code. So it still takes a human to drive this process. It still takes an organization to prioritize this process of debiasing. But you can now go do it in an afternoon the same way you would with any other type of software.
So Alex, you just had a really huge success with funding that are supporting from Apple, BlackRock, Google, Intel, Microsoft, and some of our partners as well, right? And I guess indirectly I'm also involved. So tell us about what kind of partnership are you shaping to enable your approach to become a approach of labeling in this journey?
Yeah, I mean, partnership has been, not to sound overly cheesy, but partnership has been one of the most important aspects of the project, both after spinning out in 2019, but also before that, right? So we relied on some of these great partners that you mentioned. in industry, but also on the government side. Lots of funding through DARPA and ONR and DOE and NIH and many other great agencies to actually do the research for years in the first place. But not just about the funding, it's about the participation. So getting to learn from these diverse, industry, government, science, et cetera, getting that input of what are they stuck on, what do their workflows look like? That was what motivated and led us to the whole project. And then in 2019, we spun out as a company. And, from that point on, we've just kind of the next vehicle for the project had we're looking for a different type of partner that could provide a different complementary set of expertise about how to actually productize this and productionize it and get it to customers and align, with value for those customers. And all this is to say, kind of build a company. And so since then, we've been, privileged to work with some of those same folks from the lab days, and then some new folks in the venture community to partner with to help guide us on that journey.
So what you're saying is really to implement some of your technology in place. Understanding the vertical knowledge is very critical for you, and having the right partners can give you those expertise and intelligence that can then make your technology and approach much more applicable, the applications that you're working on. And this is why you have a broad partnerships enable. How broad is your, what Snorkel is working on? Is it applicable to all industries? Or is there a certain industry that makes sense and certain industry that doesn't make sense?
So we're currently working, with most verticals in either currently or back in the lab days. So pretty broadly applicable. We currently work with 2 of the top 3 US banks and a number of others, insurance, telecommunications, healthcare, government, oil and gas, professional services, list goes on. And this is really because a lot of these problems that machine learning tackles are very, very horizontal and cross-functional. Things like understanding text, classifying or extracting information from documents or PDFs or forms or images or video. These are all very, transferable across verticals. At the same time, though, understanding what is unique about each of those verticals and each of those use cases, and in particular, what is unique about the subject matter expertise, is something that we've invested years of work into. And again, it's reliant on those partnerships to learn. What does it look like when a doctor is trying to teach something to a machine learning model versus a lawyer or a network technician or a government analyst? Those are very different. And so one thing, kind of popping up the stack a little bit is that, a lot of folks in the machine learning space, and this is part of the exciting part, like to think very agnostically to the domain. You build some machine learning model and it can be used everywhere, and you think about it kind of isolated from the particular type of domain it's going to be used in. That's awesome, and it's super exciting. But when it comes to the data, you have to actually get hands-on with the relevant subject matter experts who know the data, who know how to label it, who know how to manage it. And that's been a lot of the work that we've done, is getting really hands-on with those subject matter experts, we often call them. This is actually the very first DARPA project we ever took for the Snorkel project, was getting the subject matter expert in the loop. So spending time with those vertical experts who know the data, know the problems, has been instrumental to the core technology, the interfaces, the product now. And we spend a lot of time just talking to them, figuring out how they work with this data, what they want out of AI, et cetera. And that goes into building the tech.
So maybe, Alex, maybe this is a good time you can talk about, because not many people understand ML and really the data journey. So I know what you're describing is really the machine learning operation, right? You're really operationalizing it and using data as a tool in their operation. So maybe it'll be good to kind of show some examples from beginning to end, and how this ML ops process goes, and how do you engage, and then what the success looks like.
Yeah, so I can start with, let me start by going back to that radiology example, just because it's a peer-reviewed publication, or a set of them that I can talk to, and then I can share some other examples as well. But in that case, I think one thing to emphasize is exactly as you said, that the kind of the data journey, it starts a lot further back than many people realize in the machine learning space. So a lot of people think you just get data and then you plug it into this machine learning model and it learns to make some decisions. like the one I talked about. But it actually, there's a very, deep and intensive pipeline of what you do to get that data ready, to refine it, so to speak, for ML. So maybe I'll start back there, and I'll stay high level, but it's not just about getting data. It's first of all, how do you sample the data so that it's representative of the right populations, say the right patient populations, the right types of diseases or events that you want to make sure your model is learning to cover. So there's a first step of collecting the data that is often very labor intensive and tricky, but also has to be done in the right way. And if it's not, biases can creep in, performance can be very poor on subpopulations that you haven't sampled. So first there's the collection and sampling to make sure you're getting the right data, covering all the types of things you want your model to learn about. In this radiology example, the types of diseases or events. Then there's lots of pre-processing to get the data in a form that is uniform and processable by downstream algorithms. There's labeling, which we talked about a little bit, and that's what Snorkel and our work has focused a lot on often, which is how do you actually not just give it raw images, but images with the type of label you want the machine learning model to learn to predict. So in this case, malignant, not malignant, or urgent or not urgent, or whatever it might be. There's all sorts of other tricks that people do and end up being incredibly important to the process. And so people will do what's called data augmentation, where they, if you look at any state-of-the-art image pipeline, people are kind of randomly rotating or cropping or blurring the image to kind of teach the model that it shouldn't worry about these little types of perturbations. It should be invariant to them. And often there's work going into kind of slicing and dicing the data set to make sure that certain subpopulations are not ignored by the model. Let's say 1% of your chest x-rays have a imminently fatal event. You want to make sure that the machine learning model doesn't ignore that just because it's only 1% of the data. So picking out these important slices, or you can imagine, think in driving, something like a yellow light, right? There might be these really important subsets that you really can't ignore. So there's all this immense amount of work that goes into collecting and refining this data, labeling, slicing, augmenting, pre-processing, sampling, and all of it has a huge effect on the downstream model. Because, if we go back to machine learning 101, a basic machine learning model is really just trying to mimic what it learns from the data, more or less. And so if, your data ignores some important scenario or doesn't represent it properly, then your model is going to as well. It's really that simple. So then there's so much more, and that I'm sure you can talk to others on the show about in greater depth. But maybe I'll just stop there and say that this richness of this data pipeline is often ignored by if you look at textbooks and you look at intro courses about machine learning, a lot of them just start with, here's a data set, let's go on to the machine learning. And so part of what we've been trying to do at the Snorkel project is say, actually, a lot of the failure or success of your machine learning effort really happens in that data engineering part of the pipeline. And I think the community is starting to really get that in a broader sense, which is exciting.
Really what you're saying is at the end of the day, giggle, right? Garbage in, garbage out. And you need to make sure data is right, data is well prepared. And then with the right intelligence, you can be able to augment it with the machine to get the better outcome, which is the data journey and the importance of how you're prepping. Now, tell me about scalability. So let's assume you develop the tools, as the hardware changes and the software environment changes, framework changes, how do you scale across environment applications and over time?
Yeah, so I think there's scalability in the sense of computational processing, and I can talk about that, but that's less my area of expertise, and I'll just say that it's there's been leaps, and there are continued leaps and bounds, and a lot of the folks who are pushing the frontier, some of our shared colleagues on these technologies. Maybe just to talk about something that's maybe a little bit something that is more unique or people think less about is scalability in the sense of human effort over time as these applications change, and also as you want to build more models, right? So today organizations first are building not just one or two, but either currently building or have their sights set on building, hundreds or thousands of models. And then they're trying to scale the effort to maintain them over time as things change. And this is an area where there are huge struggles because this human effort of what the pipeline often looks like today, which is throwing a lot of people at the problem to label the stop signs or the chest x-rays or the legal documents or whatever you're teaching your machine learning model with, it really doesn't scale across additional models or over time as things change. So let's say you want to label chest x-rays and then you wanted to go on to I don't know, head CTs, or you want to go from one type of form at a bank to another type of form at a bank. You usually just have to start from scratch and start, this whole data engineering process all over again. So that's one type of scalability where, people are, as organizations, as enterprises are really starting to train their first models successfully and get them out there. They're excited and then they realize, oh crap, I've got to do that all over again. Those, multiple quarters of manual effort, of data labeling and engineering, et cetera, just to build model number two. And they're not finding those economies of scale. And in a similar vein, this maintenance over time, once, now that the broader enterprise is really starting to deploy, AI models out there, seeing that when data distributions coming in shift, the types of ways lawyers are writing contracts, the types of ways people are talking on the internet, the types of patients that are coming in, whatever your data feed is, it's the world changes, data changes. And then on the output side, enterprises and organizations' objectives change. And we can go into that later. But main point is that there's all this change. And the question is, how can you scale the human effort, both to new models and also to over time? And obviously, the Snorkel project is one way that we've tried to address that by making this programmatic. So you can kind of just reuse code and get economies of scale as you either change or create new models. But it's just of note that this is something that's kind of rearing its head for the first time for many enterprises as they begin their AI journey.
So, as you know, Lippo and I have been investing large number of AI accelerator companies, whether it's a Habana Lab that became part of Intel, or Sambanova that are also getting forefront of the technologies, or Grab course that we found in UK. Tell me about your view of the AI hardwares and accelerators, and how important are they, and what role do they play in your view in this AI journey?
Oh, I mean, that's the increasing the power, but more to the point of those great companies, the customization of hardware layers to these AI ML models and compute patterns is the cornerstone of the acceleration we've seen in the space. And so I think that used to be one of the biggest blockers. And in some sense, the whole reason I'm here, talking about data being a new problem is because we've made such great strides and we're making such great strides with unblocking around the compute, right? So the two obviously go hand in hand, and one accelerates the other. It's worth noting at a high level in terms of how this all fits together is that if you can, if compute becomes less of a blocker, then obviously data is now something that you can shift the focus to. And as data becomes more efficient to actually label and manipulate for AI, that means you're training models faster, which means you then need to make sure your compute can keep up with that faster pace of iteration on the data. And so both feed into each other. But stepping back, I think at a very high level, and I'm a software person, not a hardware person, but I've had the good fortune to sit for years next to some of those academic teams in the lab and work with them as peers. So I've picked up a little bit maybe through osmosis. But at a very high level, I think just the really incredible opportunity here is that the types of machine learning models and AI models that people use, the architectures are really converging. And so if you can, it used to be that, every single problem, not just image versus text, but, one type of document versus another would require its own custom bespoke machine learning model architecture. But today, everything is increasingly converging to a smaller set of standard machine learning model architectures. And so that presents an amazing opportunity to optimize all layers of the stack, software and hardware, for those, kind of standard architectures, which I think is one, way of describing the incredible opportunity that companies like Sambanova are really capitalizing on and driving forward, which again is super exciting for the AI space, and it's super exciting for the those of us that work on the data part of the pipeline, because that means that as we make the data processing faster, we can have the not be blocked in the compute power.
A lot of opportunities to play in data with acceleration and the frameworks, analytics. Tell me, you must have some competitors you are dealing with particularly in the data labeling business. How did Snorkel differentiate yourself, and who are your competitors?
Yeah, so I mean, at a high level, there's kind of two groups of companies out there that we often that often come out, and I'll speak at a high level to start. But I think one bucket is what we think of these as kind of model-centric AI platforms, and these are the platforms that really focus on this very important part of the loop of working on the machine learning model, the AI algorithm. And again, a lot of this has become as a byproduct of their success, a lot more push button and automated. But that's kind of what these a lot of the cloud provider platforms and kind of companies from the last 5-10 years that build AI platforms, they're kind of focused on everything but the data. And so we often partner, integrate with them, and obviously we're really focused on the data part because we see that as the part that hasn't been so nicely addressed. And then in the data side of the world, you have a lot of companies today that basically use some form of manual effort to do the labeling and curation of these data sets. And so the big differentiator for us is, first of all, we actually cover the full end-to-end process as an AI development platform. But second, we use a programmatic approach to this labeling and training of data. And one of the interesting things about that bucket is we actually, we often get questions about comparisons to these manual labeling companies, which have existed, in various, lots of names over the last 5-10 years. Same basic idea of have humans, somewhere label the data for you and send it back. The interesting thing is we almost never run into them in customer accounts, because a lot of the customers we work with can't just ship their data out to some external team somewhere of lay annotators to just label the data and send it back a week or a month or a couple of months later. Right, we're often working in industries like finance, government, think anything with PII, in either medical or telecom or insurance. It's often very private data that has to stay on-prem or internal. Often very high expertise data where it's not just labeled as stop sign. It's requires a subject matter expert like a doctor or a lawyer, a government SME, et cetera. And it's often changing all the time. So we wrote about this in our paper a couple of our papers with Google, where without naming the particular applications that we've powered for them, they have enormous resources to spend if they wanted to on asking people to label the data by hand, but they can't label the data fast enough to keep up with the change of conditions in their particular settings. So it's these factors of data being very private, requiring highly trained experts, and changing all the time, necessitating relabeling. That means these kind of outsourced human labor solutions are really just, not feasible at all. So often we're actually, going up and getting baselined against internal efforts or pre-machine learning efforts because people are just that stuck on the data. But hopefully that gives a sense of, high level, who do we often get, compared to or questions about? And in fact, we often, think that we're very complementary to those buckets in actual practice, given the uniqueness of the problems we solve.
I wish I used the Snorkel tools earlier when we were working on our autonomous driving project. There's so much data, right? Each of these devices, these cars are having cameras, radars, lidars, and each car was generating tons of information, right? Several gigabytes of data that are coming at a car in a given trip. When you put it all together, it's a gigantic amount of data you have to digest, and big indigestion problems. And having the right tools would be very useful. So I'm sure your customers really appreciate it. Now you also create this concept of application studio. Tell us about application studio, which I understand it is a host templates for common AI tasks such as a contract intelligence, news analytics, customer intelligence to help your customers to accelerate their development.
Yeah, no, it's so I think one of the important things that I think people often overlook in AI is how much the first and last mile components for a specific application actually matter, right? I think that's the high level perspective here, is that a lot of the excitement about AI and ML techniques today is actually kind of what I was talking about before around compute, is the fact that pardon me, like for those that are in the weeds and in this call on the ML space and been following, there's a class of models called transformers that increasingly are doing well at every task you can imagine. And so one of the exciting things about AI and ML, and as an ML person, I've always been excited about this too, is the fact that you can have these very standard domain agnostic AI models and techniques that just work everywhere. But when you actually bring the data into the loop and you actually think about the actual outcomes and the broader application, surprise, surprise, you actually have to customize first and last mile for specific use cases. And anyone who's actually tried to build something that gets shipped to production, is aware of this. So one of our goals in terms of actually, delivering on this, not just, labeling data or something like that, but actually delivering value to our customers, is to actually give these templates that help with the first and last mile part. What is unique about, I'll give one example. If you wanted to classify contracts for a bank, and then you also want to classify social media posts for a retailer, the AI model you use might be the same thing, but the preprocessors, the data viewers, the approaches for labeling and manipulating the data, the post processors, those are going to be very different and customized for the setting. So we've been trying to templatize those pieces based on all the great learnings with customers and users over the years, so that it can be faster for people to get to value. And the cool thing is, when you use the Snorkel technology, you're no longer blocked for weeks or months or longer on the data labeling and data prep. So we want to give you the rest of the templates that then really fully unblock you. So that's the idea at a very high level of these application templates.
Great. Yeah, these are basically templates to help accelerate the deployment of the AI operations as they are developing these tools. So let's change the subject a little bit. Tell me about your background. How did you get into AI? And I think our audience would love to hear more about what you're working on and how you got to where you are.
Yeah, so kind of roundabout. In college, I was a physics major and almost a physics and philosophy or English literature major. So I was trying to figure out what I wanted to do, and physics was very exciting, and worked on both the more mathematical parts as well as on photovoltaics for a while. But decided that it was a little too abstract, and I wanted to do things a bit more applied. So I went into after college into finance and consulting for a bit. And as I was doing that, I actually stumbled across, so we were doing some work where we were researching companies via the patent corpus, the US patent corpus. And this, and I've programmed since I was a kid, so I was always into that. And I got fascinated by this, what really is what's called a natural language processing problem. And it's actually quite interesting that there's so much data out there today that is accessible in the sense that you can download it. And in fact, the patent corpus, you can fit on the thumb drive today, right? At least if you ditch the images, and maybe even with images, I'd have to check up on that. But in terms of, but it's also so inaccessible in that, or it's so unreadable in that, if you want to pull out a fact, like what are the different key properties of different solar panel technologies, that is actually an extraordinarily difficult problem. So it's all there, but actually analyzing it is so tricky. You want to do the most basic thing, like even just normalizing all the different ways that a company like, say, IBM is referred to in the patent corpus is actually way trickier than you think because of all the varieties of human language. So anyway, I was digging into this, and this kind of led me into the world of machine learning, where people were applying these powerful machine learning techniques to actually pull information out of messy data, whether it's text or image, et cetera. That led back to grad school at Stanford and eventually to the Snorkel project. So it was kind of back through one of these types of really messy data where machine learning really offers a step change that I've been bashing my head on myself, that then led back to machine learning. And of course, once you come in through one door, you say, oh my gosh, it has applicability to not just one type of messy data like text, but so many. And that's, again, one of the really exciting things about machine learning today is the just incredibly broad applicability.
Great. That's a great experience. And obviously what you're working on has a huge implication to the development and innovation of data. Now you are CEO of also a startup company that are also unicorn status, my understanding, because we are involved on this along with my partner. So what is your business model and where are you going?
Yeah, so business models, pretty simple at a top level. We sell a software license for a developer platform, and we work with a range of teams, but generally around data science teams and also their subject matter expert collaborators. Think a data science team at a bank, but also the legal analysts or the subject matter experts that know how to label and manipulate the data and try to make that collaboration fast and easy. And so we have a standard software license model. We actually are put a lot of thought and focus into building the go-to-market motion in the team to help both with alignment before a sale and also with customer success after, because we've never wanted to be in the picks and shovels business. We want to actually find customers where Snorkel Flow is going to provide significant ROI and business value, and actually align ahead of anything. Do a really efficient but quantitative proof of value that actually shows that not just how many data points can we label or what fancy model can we train, but how can we actually achieve or support your team in achieving business value, and then help with the journey afterwards. And so that alignment has led to lots of value on both sides, and we've been humbled to work with some great customers. We're still very much think of ourselves as early days, but working with some great customers across all sorts of verticals. I mentioned 2 of the top 3 U.S. banks, government agencies. Just recently announced our partnership with Chubb, largest global P&C insurer. Work in telecom, biotech, pharma, oil and gas, others. And also, I'll note we're fortunate to work with these early customers. We're learning a ton, and so I think both in terms of the existing value, along with all of the roadmap ahead of how this is then getting scaled out to many more as we grow the team, is what we're excited about, and what our investors and partners are excited about too.
Great. So let me ask you last question. As a CEO, what wakes you up at night?
I think so. People, I get this question in recruiting calls a lot of what keeps you up at night, and the honest answer is very little, because I'm very tired all the time. I have a nearly 2-year-old at home. So between that and running and working all the time, I sleep very soundly. But in the metaphorical sense, I think for us, and I think this is true for a lot of the space, when you're in a nascent, what's really still a nascent space like AI, is are we missing out on something, or of all the options of ways we can go, are we picking the right one? And obviously that's a very fortunate problem to have, and we feel very, very humbled and lucky. But there's such a surface area of problems and things to do that are unlocked when you unblock people on the data, when you actually get them from 0 to 1. Again, you go to a team who's most of the teams we go to, they have very sophisticated people, they've got very sophisticated technology, but they're blocked on the data. And when you unblock them, there's so many things that they're excited about partnering with you to do. In the space in general, just it's exploding. There's so much stuff that any team in the space could do. And so honestly, it may sound like a little bit of a generic answer, but a lot of the tricky thing is prioritization. You have saying no to things, right? And so I think it's a nice problem to have, but at the same time, the question, am I prioritizing correctly? Am I saying no to the right, whether it's product features or customers or growth opportunities? Am I saying no to the right things? Because you can't say yes to everything, obviously, especially as a small startup that needs to stay agile.
So never-ending opportunities as a startup, and you need to get as much sleep as you can, given the job and 2-year-old and all those things. Let me ask you one last question. If you think about where we are in our AI journey, and you've been involved in this journey for a while, and AI is not new, it's been going on for a long time, but really in a way it's accelerated. If you use a baseball analogy for Americans, right? It's a 9-inning game, And a lot of times we say, are we in first inning? Are we in third inning? Are we in seventh inning? Where are we? What is your perspective?
Oh, am I allowed to call it a multi-game series and say that we're, I feel like we're in the, the later innings of the first game of the series. If I'm allowed to stretch the metaphor a little bit, I mean, I think that, there's so many levels at which, AI can provide value. So I think in terms of, this first wave of technologies and impacts where we're, seeing enterprises and enterprises outside of just, a small couple of, Silicon Valley companies and cloud providers really getting massive business value from AI. I feel like that's kind of, game one. And we are actually in the later innings of it because people are getting to value and both in general and, with technologies like ours. But that's just game one. I mean, I think a lot of what AI accomplishes today is, is actually, it's kind of like think about a lot of what AI does as almost like a better version of Command F. In some ways, it's very basic things that are universally applicable, and that's what creates the massive TAM and the excitement, et cetera. But I think there are many more games where we're going to talk about successively more advanced technologies. And so getting to the end of this first game, where this first wave of value gets delivered, is going to have massive impact. And that's where a lot of, I think, the field's focuses on. But there are many more games with many more kind of, levels of technology. So that maybe that's kind of how I think of it.
Okay, sounds like we are like a Model T 1920s as it comes out. And then, of course, you're going to have different engines that are coming that could even fly or rocket and other applications, including lawnmowers, right? So, I guess that's how you're saying there's different games in different stages.
I like that. Yeah, I think we're almost at the end. We're almost ready to ship the Model T, or we're starting to ship the first Model Ts, and we're almost at production scale. And this alone is going to revolutionize things. But there are, many other models beyond the Model T that this core idea of AI and this core technology is going to lead to. So lots of excitement ahead.
Great. I really appreciate Alex joining the Next Wave Speaker Series with me. Clearly, you have a long journey ahead of you, and I'm sure our audience hear more about Snorker and how it's contributing to this journey. Thank you very much for your time.
Thank you so much for inviting me and for your time.